screen. And I got to keep an eye on the time because quiz.
I thought it said atomic bomb.
9:31. Excellent. Now, when we did naming last day, in those names, what is missing from the middle of them that you've seen in many other names, probably last year? Roman numerals. We don't use Roman numerals to show the number of atoms. We use the charges to show the number of atoms, and the Roman numerals reflect the charge on the metal if you need to. But there's a variety of them that you don't need to. Now, you can use this page, but apparently if I try writing on this page, it just stops working because the image is too big, so I'm going to use this page. If you're in this column, here, downwards, what is the charge on every single one of those metals?
Plus.
Okay. Plus 1. So we got plus 1, plus 1, plus 1. It has one valence electron, so if it was to become an ion, it would be plus 1. Now, atoms don't have charges. Your colorful periodic table will list these charges for you. Next year in Chem 11, you would get a periodic table much like this one. But it's easy to remember. You just start here, one valence electron plus 1. What would all of these ones be? Plus 2. What would all of these ones be? Plus 3. Now this one's a semi-metal, so it may be plus 3. Aluminum is definitely plus 3. Carbon? Pardon? Go both ways. Plus or minus 4. However, if it's going to ask as plus 4, you're probably going to see it with something like CO2, which is covalent, and it's not plus 4. They're sharing electrons. So your most likely way to see it is something like Na4C, where it's acting as a negative ion, carbide, and then it's minus 4. It could be plus 4, but often if it's in the second spot, it's acting as the negative version. What would nitrogen be? Minus 3. And these all go down until the staircase line, and then it can reverse. Oxygen? Minus 2, minus 2, minus 2. And then the halogens. 1. And then all of these are 0. They won't bond with anything, so we don't care. Now, those ones, all of those, you don't need Roman numerals for. They have a charge. You can look them up on your periodic table just by counting across. But there's 2 others that also never have Roman numerals. And that would be zinc, which is always plus 2. And that would be silver, that is always plus 1. These are all on your fancy periodic table, the really colorful one as well. But one of the reasons I don't like that one, let's see if I can find an example in here. Zinc is in there, silver's in there. Yeah. For example, these don't need Roman numerals because they only have one charge. And then students will look at scandium and go, oh, it only has one type of charge as well. I guess it doesn't need Roman numerals. It does, because it can be plus 3. It can also be plus 2. And because of its position, it also can be plus 1. Your fancy periodic table, the colorful one, only puts the charges down if they rise above a certain percentage in terms of how often it's found. And so it only writes that one. But the other ones also happen. So everything on here requires Roman numerals, except for these 2 columns, these 3, and then of course for negative ones we never ever need them. Now, if you take your data booklet, turn to the page that has that, your data booklet, not your notes.
I've discovered the data.
You have discovered it. So this page has a lot of fancy information. It has this section to show you no Roman numerals, no Roman numerals, no Roman numerals. These are known as not monovalent. In addition, it gives you all the Roman numerals and what numbers they are. So there's a lot of information on this page that's going to be helpful for you when naming. So monovalent metals means one, valent means charge, and these are the ones that have no Roman numerals. We haven't even done Roman numerals as part of naming. We're going to do that next. But I've got a reference there for you to help that particular process. So we have this, we have the charges we know about, and we need to be able to name them. I was marking a while ago one of the quizzes, and someone, I think I said, draw the Bohr model of the fluoride ion. And they corrected me. They circled it and said, there's no such thing as fluoride, Mr. Neufeld, you've made a mistake. It's fluorine. That's not true. As soon as it becomes an ion, certain ones get a different name. So fluorine becomes fluoride when it has a charge. What does chlorine become? Chloride. So they all follow a fairly consistent pattern. And I just realized I haven't done attempts, and I should probably just ask people randomly to guess these. So today, E-block, attendance, Aiden, Arnie, Bowen. You should be saying here, just to confirm when I call your name. Graham?
Yep.
Grayson?
Yep.
Jamie? Layla? Liam?
Here.
Marie?
Yeah.
Matthew?
Yeah.
Miyabi?
Here.
Nick?
Say
Shh. Noah? Oh, Nick? There you go. Rachel?
Yeah.
Rose?
Yeah.
Violet? And Yuma? Okay, so for the next one, what would bromine be called? Thank you, Noah Mitchell. Noah, what would iodine be called? Iodide. Going back up to here, Rose, what would oxygen be? Rose, Rose, your voice is completely changed. It is oxide. So oxygenide, sometimes we drop syllables, that's one of them. And now I'm going to ask Aiden, what would that, no, not you, because you answered with Rose. So what would sulfur be? Sulfide. And I'm going to spell it with an F just to emphasize the point. It can be spelled with PH or F. They're both completely correct. Selenium, please, Graham.
Selenite.
Selenide. Nitrogen is Bo.
Nitride.
Nitride. And phosphorus is Murray. Phosphide. Yeah. We drop the or in there, so it's not phosphoride as some students want to do, and that's just historical. So it's just phosphide. Those pHs cannot be replaced by Fs. Those are part of the name. There is no alternate spelling. And then the piece de resistance. When lithium becomes an ion, Layla, what do we call it? No, you do. You do. Just take, sorry?
Lithium ion.
No, again.
Oh, like you said, sorry, I thought sorry.
No. Layla. No. You just say any, just, there, it's lithium. See? What do we call sodium when it's an ion? Yuma. Sodium. This is just here to belabor the point that we don't change the names of the metals. They all stay exactly the same. So they don't have a special name when they become an ion. Only the non-metals get to have a special name when they become an ion. But here, when we make the exception, is when we have something like copper. What would we call copper plus 2? Miyabi. Pardon? No, no monoditris. It would start with copper. And then we put something after it. Yeah. Roman numeral for 2. And so for copper 1, we would have Grayson?
Copper 1?
Yeah, copper 1. So we use Roman numerals to indicate the charge. They don't represent the number of atoms in the formula. They often are related because we use the charge to determine how they fit together to make an overall charge of 0. Because when we're going backwards, we have to do that. Now we'll first do these quick. Ooh, 906. We're going to stop there. We'll finish that off next day. Put your notes away. Why is this not?